This is section 2.1, basics of functions and their graphs. We're going to find domain and range of a relation, determine whether a relation is a function, determine whether an equation represents a function, evaluate a function, graph functions by plotting points, use vertical line tests to identify functions, obtain information about a function from its graph, identify domain and range of a function from its graph, and identify intercepts of a function's graph. So first thing we'll talk about is domain and range of a relation. For starters, we need to know what a relation is. Basically what a relation is, it's a set of ordered pairs. So we basically have a bunch of ordered pairs, and we'll see if we can't determine domain and range. Pretty basic stuff. Here's our set of ordered pairs: 0, 9, 10, 6, 20, 10, 30, 13, and 36, 17. Domain, of course, is our x's, and as I've gone through, I've already highlighted all the x values. So our domain is going to be the set. Usually what we do is we put them in numerical order. So 0, 10, 20, 30, 36. So those are our nice little x values. That represents the domain of our relation, where the y values are going to be represented in our range. So again, we usually put them in numerical order. So 6, 9, 10, 13, and 17. What I'm going to do now is I'm also going to talk about what makes a relation a function. So if you have a bunch of ordered pairs and you want to know, do those ordered pairs represent a function as a whole? To be a function, what you need is the x values cannot repeat. Okay, so you cannot have a repeated value in your domain. Your range value or your y's could repeat every single number. They could all be 5. It doesn't really matter, but the x's cannot repeat.